Hi, this is Yijia, and today is the seventh day of the white paper walkthrough. And yesterday, we talked about like the consensus protocol or like hybrid design, which is like it has a identity chain to selecting those to proving that you have the identity or you have the identity, the permission to actually join the transaction validation to run a fast PBFT. So yeah, so it's more like a hybrid consensus, which trying to matching the classic PBFT as fast as that, and then also can support this kind of large network with security. So yeah, that's the yesterday's lecture. So today we just want to focusing on the other part of the chain infrastructure. Um, so today is more focusing on sharding and the virtual machine. So sharding, I think lots of people heard about this, and lots of projects actually doing sharding, and then so you know that we need this kind of like a scalability improvement, right? So So the reason for like why we need this kind of sharding is because like a current blockchain's design is more focusing on like each node store all of the on-chain data, and all of the node need to like a processing all the transactions, like all has the ability to actually process all the transactions, and so it actually largely like protect the security, but it actually sacrifices the performance a lot. So which is true. Like all of the nodes, think about like that. All of the nodes store all of the data, and then all of the nodes can process the transactions, and so when like parts of the nodes down, it doesn't matter to the blockchain because so firstly, it's like all of data has backup on the other nodes, and secondly, it's those nodes also can do like a computation. So that's why I say okay, it's pretty secure. You even you take down part of the network still as I mean strong, still can do the work and they finish the job. Um, but for sharding, it's like you think about like divide them into I mean you just intuitively think about like divide them into 10 groups, and then if you assign the job to uh, equally to tens of them, and then you only store like a data equally to tens of them. You think about just you take down one group, and then maybe the data stored on that group will lost, right? So that's the normal intuitively way. Think about like why like sharding may decrease the security, right? So sharding usually uh, dividing into two parts. One is like a computation sharding, the other is like a state sharding. So computation sharding is more like all of the nodes still like have all of the data and store all of the data. But only like saying like when I validate the transaction, when I run the execution, um, I divide this work to different like shards. So even like take down part of the shards, it's more like that work that validation may I mean may lost, but there's no data lost. There's no data availability problem for this kind of like a computation sharding. It's more like you just like a shard the computation work, shard the validation work, but you don't shard the storage, right? So state sharding is more like you're not like store all of the data on all of the nodes. You separate the data. Maybe some nodes like stores part of the data, the other nodes store the other parts of the data. So the problem is like maybe like say if you take down the whole shard of like one shard, then there's some like data loss, right? Because you share the data to that part. So there are like lots of like design to like Ethereum's like a new design about to more private, more protect those kind of data security, or like well when you do state sharding. So yeah, this is a complicated stuff. And there you can, yeah, if you're interested in that, you can just like refer to see that part. But yeah, so for our design, it's more like we focusing on like a computation sharding. The reason we do that is because like some of like our like private transactions, we need to support like a public transaction, and also like a private transaction, and the private, like a private preserving smart contracts, and those kind of validation sometimes are like a different than the normal ways. And then and we want to using this kind of computation sharding to actually speed it up. So this is the basic idea why we plan to do that. So the way we do that is like firstly we split the nodes into like multiple groups. Then each group actually process a subset of the transaction. So it doesn't need to like process all of the transaction because it's shard, right? And so you may, and you may think about it's like, how do you like randomly like or like you how do you shard, how do you like divide them? You need sort of like a random number, right? Or like a random stuff. So we use a BS signature to generate a random number. So it's more like a secure domestic like a random generator. So you can use that to actually shard the computation. And the shard assignment will be recorded into the like identity block, so that user can actually like refer to that identity block is to find out, okay, which transaction is in which shard. So everything is get recorded, right? So there's an intuitive thing about it. It's like you can think, okay, we can use a standard address as a transaction as the sharding criteria. So it's more like all transaction from the same account will be processed in the same shard. So there will reduce the dependency, right? And think about that. So user A send transaction to user B, and also he send the transaction to user C. If you separate those two transactions to different shard, then maybe there's a dependency issue. So after A send transaction to B, the amount get decreased, and then when he send the money to C later after the transaction to B, the actually like a account balance changed. So if you do that parallelly for in different shard, then there's a dependency issue, right? So then you need to cross shard for communication. But if you shard all of the A transaction, like starting from A to one shard, then you will do this like one by one, right? So after you do A to B, then you do A to C. So there will be minimize the cross shard communication. So that's like a basic idea. And so this is the basic idea for our like a computation sharding. We also trying to like adopt like a state sharding. Yeah, in future plans. I don't want to like talk more detail about this now. Yeah. So besides that, we also like have our design for like virtual machines. So I want to give some like an introduction for virtual machine today, and yeah, we will go to some more details tomorrow. So usually like a virtual machine is like a state you, especially it's important for like smart contract, because you need that virtual machine environment actually to run the smart contract. So our design is trying to like a based on the WebAssembly. So by this way, it's like a WebAssembly is like a it's a format that or like a standard that lots of like browser or different environment can actually support. So by this way, it's more like it could like support like multiple program languages input. So this is more like tutorial stuff. It's like a developer write a smart contract, and those smart contract compile to a bytecode. It doesn't the blockchain actually doesn't need to store the whole like a smart contract. It doesn't. You need to store the bytecode, and then the stuff get. So when you're trying to run the smart contract, then actually it runs executed in the virtual machine, and then you finish the job. Yeah. So this is more like a basic tutorial for like virtual machine. I will talk about the, the detail design or like a detail stuff for virtual machine tomorrow, and tomorrow I will try to like bring up some like trust model to talk about, and yeah. So thanks for listening for today, and yeah, hopefully you learn something, and then let's talk about more stuff tomorrow.